Okay, let's check it again. So I'm going to take the spur gear, turn it, and you can see that the shaft is now turning with the spur gear. Perfect. Perfect. Okay. So on this end, what we're going to do is we're going to create a quick little handle. So it could be a new part. Since this shaft is extremely thin in diameter, we're going to create an additional cylinder. Or let's do this. Let's just make it simple. We're going to go ahead and extend the shaft. So let's see if we can extend the shaft. So let's go ahead and double click on the shaft. We've got the extrusion that we're going to be working with here. So we're going to edit this feature. And let's see if we type in 3.0 inches, if that's going to help. Return. And yeah, gives us a little bit more room off the end. So what I'm going to do is I'm going to put in a really basic handle. Let's go ahead and put a hole in the shaft. Let's double click on the shaft. We're going to go ahead and put a work plane on the outer edge of the shaft. To do that, we pick the work plane, select the outer surface of the shaft, and then we have to use in the browser window one of the origin locations. YZ will work, XZ will work. I like XZ better based on the direction that I'm viewing, so we'll leave it there. So now we've created a work plane on top of the shaft. Let's go ahead and create a 2D sketch on the work plane. Okay, it flips it around. I'm going to go ahead and go back to the home view, rotate it so we see the blue surface. Perfect. Now we can also look at it in a plan view onto the work plane. And I'm going to make a circle, I'm going to project the geometry first. So I'll project the edges of the shaft, locate a circle based on the midpoint, bring it straight across, and the size of the circle is going to be dimensioned at 0.1875. 0.1875. We'll then finish the sketch, extrude the hole, and the depth of the hole right now it's a 1/2 inch, and we're going to cut it into the part. So if we want to see how deep it's going to go, and it's going to go right through if it's a 1/2 inch. This is a very small shaft. So we're actually going to drill it all the way through the object. And I need to select the surface. Let me cancel it and try this again. So we're going to extrude that shape, cutting it, flip the direction, all the way through, and accept it. So now that there's a hole through the object, let's return back out. And as we said, it's always good to check to make sure things still work. So I'm just going to grab the spur gear, move it up and down. So far, so good. We're going to create a new part. So we're going to create a new part. We're going to call it handle. On the new part, we're going to make it based on the work plane. It's got a sketch on it already. We'll look at the work plane. We'll project the geometry or yeah, we can project the geometry, but it's going to be in 2 circle halves. So let's do this. Let's draw a circle. We know that the size of the circle is going to be 0.1875. And we are going to go ahead and extrude it. So we'll finish, extrude, and the length of this will make this about 2.5 inches. When we return, again, you'll notice that we have a flush constraint on the handle, that it's flushed to the bottom. Let's go ahead and check it and see if it actually still moves. It does. So if I grab the handle's not constrained, is it? But it does move with the hole. So let's go ahead and constrain the handle. If you'd like, we can leave the flush constraint there. That's one option. We can put a ball on the end of the handle, but realistically, any accoutrements that you want to add to the handle, that's good. What I'm concerned with is making sure that this handle is centered throughout the hole and that it doesn't move. Now, we said that it's flush, it's now centered. Now let's see what happens when I grab the handle. When I grab the handle, it now moves with the object. So this is a really simple way to manage a handle. Okay, so now we still have the rotation, we have the movement of the spur gear, we've got a handle, and now let's put the rack in. So we're going to constrain the rack. How are we going to do that? Well, the face of the rack needs to be constrained to the face of the surface, and we can also provide a slight offset to that. So again, I'm going to go surface to surface. Let me do it correctly. Surface to surface. But I want to put a slight offset here. We did about a 32nd, 0.03125. Actually, we did a 0.01875 as our previous offset of the spur gear. Now let's see, is that going to provide too much of an offset? No, I'm looking down. We should be good on the... sorry. Made a mistake there. That happens. Let's try that again with the applied constraint. So I'm going to go ahead and apply the constraint. Offset of 0.01875. And apply. Now what I was looking at was from the top down, I was able to see from the bottom direction the actual position. But you notice that the rack isn't positioned properly. So we'll do another constraint from the top surface to the top surface, and we'll make it flush. Now we may end up having to remove that flush constraint, but I wanted to have it there temporarily for us to work with. And the third constraint is going to be side to side. So again, we're going to have to go from the side of the object to the side of the column. And we'll put in 0.01875 is our offset, so that way we leave some room for adjustment. And so now the rack is in. But what the rack doesn't have is any relationship to the spur gear. And the rack doesn't move. Why? Because we added that flush constraint. So under the rack, let's go ahead and suppress the flush constraint. Let's see if it moves up and down now. Yep, moves perfectly now. So we're good. We're good. I can actually go back and delete that flush constraint if we choose to. Let's go ahead and turn the visibility of the column off temporarily so we can see what's going on. Whoop, wrong object. I want to keep the rack visible. I want to turn the column visibility off. There we go. Okay, so now we have to work with the inner meshings. Let's go ahead and turn off this cover plate also. So now we're going to work with the inner workings of a gear and a rack. To do this interaction, we use another constraint, and it's called rotation translation. And what that means is that we're going to take a round movement and translate it into a linear movement. So from the spur gear spinning, we're going to go ahead and make the rack move up and down. It's all based on pitch diameter, which is where the two gear teeth mesh. That's the point of mesh. And so there's a slight equation here when we put this constraint on. So we're going to go to a motion constraint. And the motion constraint is rotation to linear. It's called rotation translation. And we have to use an equation because the distance is a function of the pitch diameter times pi. So whatever the pitch diameter is times pi is the value that you need to put in for the distance. If you don't put that in, then what happens is the spur gear spins too fast in relationship to the rack teeth. Or if you use it for a gear-to-gear ratio, the same thing will occur. So the spur gear has a pitch diameter of 1 inch. So it's 1 inch times pi. Okay, that's the distance. The first thing that we select is the face of the spur gear, because that is our rotation. The second item that we select is the edge of the rack. So I'm going to select just the edge. I don't want a face, I want the edge of the rack. And apply it. Once applied, I should be able to grab the handle, and things aren't working right, are they? Okay, so we've got some tweaking to do. Or do we? Maybe it's because of the angle that I was working in. So let's take a look a little bit closer. So here's the problem, right? The gears turn in one direction and the rack is moving in the other. That's a problem. So under rotation translation, if we edit this, you'll notice that we can control the direction of the spur gear rotation. I need to take it from forward to reverse. And now, when I apply it, they should mesh perfectly. Right? They're turning in the right direction, but the gears don't mesh. So here's how you fix that. Temporarily suppress, adjust the rack to be at the proper location so we get appropriate mesh, and then unsuppress. And so when it moves, all you do is an alignment of the gearing. So let's go ahead and unsuppress all the other features. We'll start with the bearing plates first. Turn them back on. And we'll grab the handle. And things aren't working as well. So this part works well. Is it still meshing? We can check. How can we check? We can turn the visibility off of the plate. Okay, so now the handle caused an issue. So let me suppress it, adjust it, and then unsuppress. Okay, and so what we need to do is we need to look a little bit more at the connection between the handle and the spur gear and why that is not meshing properly or is not working properly. So let me unsuppress the other components and see if that plays a part. And it could be because I can't control the selection of the handle very well. So we have a tool for that. Okay, because if I move the rack up and down, it works perfectly. But I have a tool to control movement. And it does require typically a work plane. And it's an angle constraint applied to a work plane and a surface. So in this case, we're going to go ahead and set the angle constraint from the work plane to the top surface. And it's a simple 0-degree angle constraint, and we'll apply it. Well, that angle constraint that we just put between the column and the handle work plane, I can use as what is known as a drive constraint. And so what that will do is that will allow me to move. Let me go ahead and do 60 degrees. And so we're going to start at 0, we're going to move it at 60, and the handle will move. Well, realistically, I should probably go, let me go ahead and move it back, so maybe we should go negative 60 instead. And so what I can do with this drive constraint now is specifically locate and provide step values, repetitions, how fast it's going to move, detect if there's a collision between objects when I work with the drive movement. So let's go a negative 120. So that's about the bottom. If we move it to the top, instead of 0 degrees, we can have it rotate back to 0. So instead of 0, let's go ahead and say positive 90. And notice that the handle follows. So let's go positive 180. And that's about appropriate. A little bit more, probably about 220 is about where we need to go. And that's about as far as you can go with the handle for the rack in this direction. So now when I hit play or reverse, that goes way too far. So negative 120 is way too far. So let's go negative 80. Let it reset. Uh-oh. Negative 80 isn't working real well. And so now I need to reset these. So let's cancel this. It resets automatically when you cancel because it goes back to the 0 position where it was. You notice that the 0 position is a little bit low, but it provides us a good starting point. So theoretically, that's about as far as we can go in the down direction with the spur gear. Maybe a little bit farther. But we can do the same thing. Drive constraint. We'll say negative 30 to 220. Let's see what happens. Perfect. Let's reverse it. Perfect. And that's about as far as you can get with that spur gear between those two angles. Could you calculate the exact position based on gear teeth? Definitely. You can turn everything off, see where the meshing occurs, where the meshing stops. If we change the visibility of this, I'm going to go ahead and apply that. You'll notice that there's also a record button. I can record this movement. So this now becomes an animation that I can record and send to a potential client or a customer, showing them the movement of the actual assembly itself. Again, the reason why the handle doesn't move very smoothly is because I couldn't get a good grip on it. If I moved the rack up and down, the handle moved appropriately, so I knew it was just the grip aspect of the handle. Have a great day, and we'll talk to you soon.